Okay, here, hopefully you try this mock quiz, and we're going to go over this right now. And this is quiz problems on Pythagorean theorems and distance formula. Okay, first one first. If a triangle's three sides are 6, 8, and 11, what kind of triangle is it? Is it an equilateral triangle? Is it a right triangle? Is an obtuse triangle, an acute triangle, or none of these? Okay. Um, let's go with this one. Obviously, and we know it's not going to be a equilateral triangle. Equilateral means all three sides are the same. So this is 6, 8, and 11. So it can't be A, all right? So maybe we want to label those. We label A being 6, B is 8, and C is 11. Okay. So now, if it's a right triangle, A squared and plus B squared, it gotta equal to C squared. And so if it's a right triangle, uh, it should, both sides have to exactly equal because that's the ancient Pythagoreans had figured it out. Okay, so in this case, 6 squared is 36. And if for that to be a right triangle, we know the C squared has to be 36 at 64 is going to be 100. Okay, so if C squared is 100, and if if C squared is equal to 100, then C has got to be equal to 10. And also you realize that we did this pretty good, okay? If it's a right triangle, if it's 6 and 8, the hypotenuse got to be 10, right? Okay, so if the hypotenuse is 10, that's a right triangle, okay? But unfortunately, C is 11, so we know this triangle we have is not a right triangle, all right? So if it's not a right triangle, then what is it? And just let's draw the picture, okay? If I keep the 6 and 8 and 6 and 8, and if it's 90 degrees, and it will be a right triangle, but 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 unfortunately, as you realize that this is 6, this is still 8, but the the longest side is actually it's 11, okay? So it's actually what? It's actually longer than 10. So now, if you by looking at this, what kind of triangle is it? This is actually a what? It's a obtuse triangle. Okay. So how does that work? Now, if you did 6, so in this case, 11 squared is going to be 121. So in this case, A squared, which is 36, plus B squared, which is 64, is less than 121, which is C squared. If you put those in there, if the longest side squared is bigger than the other two sides squared added together, you have an obtuse triangle. Okay, that's exactly a case we got here. All right. So how do you have an acute triangle? So let's say if the C is equal to 9, okay, the other two sides being the same. So if that's 6 and this is still 8, now as you can see, if it's 10, it will be a right triangle. But if that's a 9, then as you can see, that's a acute triangle, okay? So you realize that in this case, if it's a acute triangle, the 8 squared plus b squared will be greater than the longest side squared. Okay, so if it's the two shorter squared added together is less than the longest one squared, you have obtuse triangle, like what we have here, 6, 8, 11. If the two shorter ones squared is longer than the longest side squared, you have acute triangle. And obviously that's not the case we have here. Okay. And none of the above, that's not true because we found a winner, right? So in this case, this is the scenario we have here. Okay. So if it's obtuse triangle, this happens. If it's a right triangle, two sides should equal to each other, but in this case, that's not true. We don't have a 10. Okay. We don't have it. We had 11. And if that's the case, you have acute triangle. All right. Okay, so that's how we decide whether, if I give you three sides of a triangle, and we can decide exactly what kind of triangle we have, right? Those are the criteria. Okay, number two, what is the distance between 2 points? In this case, 1 and -2, that's the coordinates for the first point. 4 and 2, that's the coordinates for the second point. And what's the distance formula? Distance formula is actually, if you remember, that'd be great. If you don't, that's also fine. Distance formula is just an extension of a Pythagorean theorem, okay? So it's the y value of the second point minus y value of the first point squared and plus and x2, second x value minus the first x value squared. Okay, that's the formula. All right. Now, so you had to put the correct values in the right spot. So here, this is the first x value we come across from first point. This is the first y value on the first point. Here's the second x value. So just label them, okay? And that will reduce the chance of having you making a mistake. So next, once you figure that out, just plug in the correct values, okay? So now, before you do this, I will suggest that you replace y2, y1, x2, x1, put a parenthesis there to occupy its place. This way, as you will see, it will minimize your chance of making a mistake, okay? Because we do have a negative number lurking around there. Okay, so now you want to put those values in there. So y2 is what? Just come over here. y2 is 2. So 2 there. y1 is -2. Okay, there you go. Okay, so if you did this way, you see double negative give you a positive one. So x1 is 4. 4 minus 1. Okay, so let's keep going. So 2 minus -2 is 2 plus 2. So that's 4. 4 squared. And plus 3 minus 1 is 3, so 3 squared. And you have 16 plus 9. Because 4 squared is 16, 3 squared is 9. And add them together. You have square root 25. And we know that all distances are positive values. So square root 25, we take the positive value, it's a positive 5. Okay, so therefore, the distance between those 2 points is 5. Okay, so if you run into a problem like this, distance formula on your quiz, just take it slow, label all your points, and replace all the variables, put a parenthesis there, step by step, you'll get the right answer. Okay, we're not testing how fast you can do it. We're testing whether you can get it right or wrong. So take your time. Okay, number 3. If a right triangle's hypotenuse is 10 and one of the leg is 6, how long is the length of the third side? Okay, so always start with do a sketch, okay? Do a sketch. That would make things a little bit clearer for you. So that's the hypotenuse, the longest side, the side opposite of the right angle. So label that, that's being 10, okay? So one side is 6. And what's the other side? Put a question mark there, right? And we said that's a right triangle. If you have a right triangle, what can help you solve these problems? Pythagorean theorem, because if you have a right triangle, you can use the Pythagorean theorem. Okay, so let's label them. All right, so we want to label the hypotenuse being 10. We can label this side known to us as A. We can label the question mark as the B. Okay, so we just stack them up. So we know it's a right triangle. So this is true. So A squared plus B squared equal to C squared. And plug the numbers in. So A squared is 36. And B squared we don't know. And we just write it down as such because that's the one we try to find. And C is 10. 10 squared is 100. Okay. So what we have to do is subtract 36 from both sides and following that line of thought. So B squared is equal to minus 36 on both sides is equal to 64. 100 take away 36 is 64. And how long is B? B is going to be the square root of 64. You take a square root on both sides. So 8 times 8 is 64. Okay, so here we go. And as you realize, this is a 3, 4, 5 special right triangle. So it's 6, 8, 10. If you know your special right triangles well, you probably know the answers right away. You don't have to carry out this Pythagorean theorem. Then that's all the power to you. That's why we emphasized special right triangles in the classroom day after day. Okay, so you work smart, and even better, work hard is good. Work smart is even better. Okay, so here are the first 3 problems. Okay, so you have to decide what kind of triangles you have, carry out the distance formula, and give you 2 sides of a right triangle, and apply the Pythagorean theorem, and figure out the missing side. All right, I'm going to erase this, and we can move on to the last problem. Okay. There's probably a better way of erasing this. And so let me just do this. Whoops. Okay. There's always the first thing for everything. Okay. So, all right, bear with me, almost there. And we can go tackle the last problem. Okay. So I think it did a decent job erasing all the stuff. Okay. All right, so now let's take a look at the last problem. Problem number 4. In a 45, 45, 90 special right triangle, if a leg is 25, how long is its hypotenuse? Again, do a sketch, okay? So, 45, 45, 90 is a special right triangle. It's actually an isosceles right triangle, okay? So those two angles are equal to 45, that's 90. And we set the legs are 25. And they are isosceles, so both sides are 25, okay? The angles are 45 degrees. Now, if you remember what we did in the classroom, and you can use the special right triangle knowledge, and you realize the hypotenuse here in 45, 45, 90 is just simply equal to the leg times a square root 2, okay? Multiply by square root 2. So the answer for this one, how long is hypotenuse? It's literally, if you know the knowledge of 45, 45, 90, hypotenuse is just simply the side times a square root 2. You're done, okay? And you got that right too. What if you don't remember this piece? What you can do is, just like problem 3, you can do a Pythagorean theorem, okay? So if you don't know, and if you don't know that special right triangle piece, then you have to do the hard work. You have to go use Pythagorean theorem. So this is C, and both A and B equal to 25. Okay, and since it's a right triangle, A squared plus B squared is equal to C squared. And so you just plug it in there, and 25 squared plus 25 squared, and it's equal to C squared. So this is actually equal to what? 1. So you have 2 pieces of 25 squared. Okay? That's equal to C squared. So what is C equal to? You have to take a square root on both sides. Square root of 2 is square root 2. And square root of 25 squared is what? Is 25. So again, if you did the Pythagorean theorem, you get exactly the same answer. 25 times square root 2 is the same as square root 2 times 25. Okay. So that's how you work those 4 problems. And like I said, the quiz you're going to take will be very much like that. Okay, if you have any other questions, you can ask me in person, or you can look at this video again. All right, we will see you next time.